In this hour, we're going to talk about the fun stuff. This means we're installing SIPs. This session, entitled Layout and Panel Installation, means that we really get into the heart of what we do. We install panels, and that's what it's all about. The objectives in this hour that we're going to go through are going to cover the basics of installing, some of the things that differentiate between installation of walls and roof panels. We're going to get into how to stay efficient and things that we need to do to make sure that the panels that are going up properly as well as efficiently. We'll talk a little bit about tools and techniques, some of the various specialty tools and maybe the tools that you already have in your bag of tricks at home. We've already talked a little bit about preparation for trades, but we have to continue to think about that preparation as we put panels up. So we're going to discuss a little bit about the thinking ahead for the trades so that the trades job is easy both while we're on site and after we leave and the panels are done. Rigging is a big thing. We'll discuss rigging and some of the liability issues and the safety issues with rigging and how it differentiates between wall and roof rigging. Of course, we're going to talk about installation, so that means we're going to talk about sealing panels. And when we talk about sealing panels, we're going to talk about it a lot because you don't have a proper installation unless you've sealed the panels properly. If they're not sealed, it doesn't work right. So we're going to emphasize that a lot. I'm going to talk about labeling. Why do we label? Because label is part of communication. And if we label panels, it means that the people that follow us, the other trades, know what's going on inside of a panel. Think about it. The panel's solid. You can't look inside the wall. You can't see what you've done on the inside to get ready for other trades. The electrician needs to be able to see that and understand what those communications and those labels are. In addition, we want to talk about the weather issues. When you're installing panels, we still have weather issues to be concerned about. As always, we don't want panels getting wet, and if they do, we got to let them dry out. So let's think about those sort of things. We're going to talk as well, a big part about this part of installation of panels has to do with what's going to come in the future in Phase 2 training. If you ultimately receive the certification that the association is providing as part of this course, it means that you're going to end up on site working with the tools and proving that you understand the techniques that are needed, which include modifying panels, rigging panels, setting panels, and most importantly, sealing those panels. So a lot of what we're talking about today, you're going to have to put into practice when we actually get out into the field. First thing we're going to do when we start setting panels is look to the drawings. As always, whenever we're building, we've got blueprints. Those blueprints are the key to how this project goes up. And as we talked about in earlier chapters, these panel layout drawings are really the instructions of how these panels are going together. If we're dealing with fully fabricated panels, we've got panels stacked up over there ready to install that all have labels on them. And those labels should match the drawings. That needs to be checked and verified. And then we need to start putting these panels up in an order that makes sense. We have to look at the drawings to verify that what's on the ground matches what we're putting up. Now, these same drawings need to be reviewed to a great extent to verify that everything has been thought about in terms of the review for things like rough opening, for pitches, for locations of point loads, as well as locations for the other trades. It's the review of these drawings and these panel layout, if you will, to make sure that this project will move along uniformly. If the package that you've ordered is not prefabricated, it's these panel layout drawings that are really your instructions for how to start cutting panels. So now you're working with not only blueprints, but perhaps panel layout drawings, and as the tools and modification of these panels so that when you put them up, they match what it is that the architect has drawn. And this is incredibly, potentially difficult, as when you're cutting panels on site, you have to deal with things like yield. Yield in terms of a complex joinery and trying to get the best possible yield out of a rectangular piece of panel. When the manufacturers who use CAD design and CAD equipment, they use something called optimization, or actually software that nests all the various shapes and sizes and components into whatever size panel they're pressing. If you're cutting these panels in the field, you have to think optimization while you're working with the panels, cutting them out in play. So working with these layout drawings, working with your blueprints, and understanding the optimization required in order to get good yield might make the difference between whether or not you've ordered enough panels or not. You don't do a good job at figuring out how to cut these panels on site, and you might not have enough panels when it's all said and done. Panel prep is something that I advocate to all installers. Why? Big reason, safety. It's easier to work and safely to work with your feet on the ground than it is up in the air. So what do I mean when I say panel prep? I mean we're going to take these panels to the point where the entire package is ready to start installing. I also do this for another big reason, and it has to do with money. Using equipment to set all these panels when it costs at somewhere between $100 and $150 an hour can add up very quickly. So the panel prep is a key element. I've seen inexperienced installers make the mistake of ordering a crane to show up at 8 o'clock in the morning when they thought their panels were going to arrive at 7 and start setting. It just doesn't work that way. You need to get panels on the ground. You need to think about prep. And when the panels are prepped and they're all ready to stand up, that's when the equipment typically wants to show up. That's when the crane shows up and the clock starts ticking for that expensive piece of equipment. Panel prep should be done to the most extent that you possibly can do. This includes drilling for electrical, pre-drilling for all of your screws, figuring out any lumber that needs to be installed, putting panels together. This actually falls under the heading of pre-assembly. Now we're not just taking panels and prepping them, but we're actually pre-assembling them into groups. It's a wonderful thing if we've got 30 roof panels to put up in the air and we can combine them into groups, and the next thing you know, we now only have 15 lifts. That's going to shorten the time for that crane operator to work, and it's going to save you a lot of money, So think about pre-assembly, put as many groups as you can together, and let's fly them up there in as few lifts as possible because we're covering up big areas at one time. All right, it's time to set the first panel. Where are we going to start? Well, the best place to start is typically at a corner. Why? Because it self-braces the package. You probably already know this if you've installed SIPs. Once you put one panel up and turn the corner, you all of a sudden have a very strong and rigid assembly. In fact, some people would suggest that you can put up an entire SIP package and never brace anything. I don't know that I typically agree with that. It depends on the height of the wall and the size of the wall. But I will say that the amount of bracing that's required on a SIP wall package is typically significantly less than is required on most stick frame assemblies. The big difference is with a solid SIP wall, it acts like a sail. Again, you have to be mindful if you've got any wind situations coming up, don't leave that wall unbraced. You want to make sure that you get it braced. But let's start at that corner, turn the corner with 2 panels, get everything plumbed, get it tacked down to get a good starting spot, and let's go from there. Now, when we lift panels, even wall panels, rigging comes into play. Rigging is something that we need to focus on from the perspective of safety and efficiency. There's actually very few methods of rigging that conform to the standard which OSHA has established that says rigging requires a positive attachment. What do they mean by positive attachment? It means that nothing can let go or fail and allow whatever it is you've picked up to fall to the ground. Work with your manufacturer to verify that they have provided you some methodology for rigging panels. Now, when we get into phase 2, we're going to work with a lot of various things in terms of rigging panels, whether it be lifting straps or lifting plates, which are most commonly used. What I'd love to use when we're setting wall panels, of course, is to find a convenient window or a door opening that I can actually wrap around. One technique that we'll also use is we'll put top plates in temporarily and literally put loops or rigging into that panel so that we can either abandon that strap underneath the top plate, or in some cases we'll literally drill through the panel and we'll loop in through that hole. Of course, that means we've got a hole in our panel package and we've got to go back and fill it up. So it's a give and take situation. Do we drill a hole and have a safe rigging situation at the expense of having to go back in and fill the hole? In most cases, the answer is it makes sense to do that. Have to make sure that the rigging, whatever you use, is always done safely. If you are drilling those temporary holes and running the strapping through them, it's a good, safe way to have positive attachment and nothing can fail. If you're rigging panels for a pitched roof, a couple things you have to be careful of, and that is to rig the panels with the pitch already in play. Where this may bite you in the butt, however, is if you start getting a windy day. If you have a windy day and you have a panel hanging at a pitched angle, it'll start to spin on you. And when it starts to spin on you, it can go for a heck of a ride. If you have rigging on a roof panel on a windy day, we often want to take those roof panels, instead of flying them in a pitch, is drop them down in flat, and the wind flies right by, and it doesn't become as much of an issue. When we rig roof panels, we want to make sure that, of course, we have positive attachment, which means, again, we have to drill through the panel and to put something on the bottom, which acts as a plate or a pin or something that prevents it from coming off. What we don't want to do is we don't want to wrap around the entire roof panel, because when we do that, we prevent the ability of you, the installer, from taking one panel and mirroring it to the next one and attaching it in a spline configuration, because your lifting mechanism is in the way. You can't do that. Keep that out of your way. Don't forget, we also need to find a handle on this panel. We need to be able to hold on to it. When that panel comes in off of a crane line, the person up on the roof needs to be able to get a hold of it and move it into position. This is where ratchet straps often come in handy. We can attach any number of types of lifting plate or attachment configuration panels that allow us to get a hold of this panel and move it around safely. Panel adjustment is absolutely critical. Whenever you get a panel into play, the next thing you need to do is make sure that we can adjust it into its final resting place before we put a nail in it and call it good. As we're putting wall panels up, eventually we're going to get to a floor. When we put that floor system up, depending upon your design, you've got a couple of different options. Was that floor system a platform framed floor, or is it a hanging floor system? Or maybe, perhaps like we often do in metal roof panel structures, is we'll balloon frame the wall and go from the foundation all the way up to the roof line, and then we attach the floor system to the inside skin of the panel. There's a variety of different ways to do that, but what we need to keep in mind is that as you're installing these panels, eventually you've got a floor, and if you're the builder, a lot of times it's the installer's job to go ahead and put in any load-bearing partitions and the floor system so that we can keep installing the panels. What I'm trying to say here is we don't want to jump back and forth between different trades. If you are the installer and only the installer, you may want to consider doing some of that framing work so that you can stay on site and keep moving forward with that SIP installation without having to stop and let regular carpenters and framers come in and frame other systems. Keep that process going, and always know that you may have to apply your talents towards framing up things like interior partitions, load-bearing partitions, and certainly floor systems. As we're installing panels, we're always thinking about other trades. A good installer is thinking about other trades because that's what makes him a good installer. Why? Because as he moves from panel to panel, he's constantly thinking what's going on inside this panel that affects somebody else. Most importantly, it's going to be the electrician. Why? Well, because the electrician question seems to come up a lot. How do we run electrical in panels? It's not that difficult, but it requires communication. Communication in a lot of different forms. Communication in terms of writing on panels, as well as communication with a site meeting, a meeting before we even stand the first panel up. Or in a lot of cases, while we're standing panels up, if we can get the electrician onto the site and work with him to show that individual how it is that we're labeling panels, how it is that we're giving him access from point A to B, makes the electrician a whole lot happier, and he's much more inclined to do a quick, efficient job in running his electrical through there. When we meet with other trades, what we're really trying to do is we're trying to explain this system to that trade, whether he's the electrician or the plumber or the HVAC contractor or anybody else. What we're trying to show them is how these panels go up and how their work is going to interface with this panel package. That's key, because we don't want them showing up and all of a sudden have unexplained or unwarranted cost increases just because of their unfamiliarity with the panel package. This is why we need to keep those costs down by meeting with these people and showing them what they're going to be dealing with. When you need to make these modifications, it requires a few special tools. You've probably got the lion's share of tools already. The investment that I tell people when they go into full-time SIP installation and to be the most efficient, well-outfitted crew that they could possibly be, they're probably not going to be making an investment more than a couple of $1,000s in specialty tools, depending upon what type of panels that it is that they're going to be installing. The biggest tool, the most important tool that you'll ever have, is the tool that helps you seal panels. That may come in the form of a foam gun. It may come in the form of tape, which isn't really a tool, but it helps you seal those panels. As we're putting panels up, panel by panel, we're always thinking about how these panels get sealed. Now, depending upon which manufacturer that you're dealing with, what type of panel, there's many different techniques of sealing. There's many different types of things that are used to seal panels. They could be a panel mastic, which is nothing more than a caulk delivered out of a caulk gun. Very commonly, it's some type of an expanding foam. Now, there's both single component as well as two component foams. You also sometimes will see gaskets. You're also going to see tape, and the tape is sometimes that belt and suspenders approach that we'll talk about in a second. But let's talk about the two main ones, and that is panel mastic and foams. When I'm training people how to install panels, I tell them that I want them to think like a molecule of air. And if you can think of a way to get through that wall or roof assembly as a molecule of air, you've just failed at properly sealing that system. So every panel that goes up, every joint needs to be addressed as to how to prevent air from getting from the outside in or from the inside out. If we're using panel mastic, that panel mastic is typically provided by the manufacturer as part of the accessory package. Panel mastic's not real expensive. Don't be too frugal. Use a lot. Use a little more. Use a whole lot. But make sure you use enough to stop air moving through. The most common techniques of panel mastic are going to be a 3-bead system, where we're applying a bead of mastic on either side of the panel as well as on the foam, so that when we slip down over lumber or over a spline, we've got 3 potential paths of stopping air moving through that system. Some manufacturers don't use panel mastic to any great extent. Instead, they use expanding foams. Let's talk about expanding foams for a moment. You have both single component as well as 2-component expanding foams. There's a big difference in cost and in usability and functionality of these different types of foams. Single component foams typically are delivered in a can, a small can that can be delivered through a straw or a gun, and the screw can fits onto a gun and allows you to apply the foam wherever it need be. Most important to understand is this type of foam, as a urethane foam, needs moisture in order to cure. This is critical. Why? Because if you don't have enough moisture in your system, the foam won't completely cure. In fact, single component foams will only expand to the maximum of about 1 inch without any added moisture. So this means if you've got a crack that's 2 inches wide and you're trying to fill it with single component foam, you're going to fail unless you lay it down in beads, you apply moisture to it, and you give it time to expand and grow, and then lay more beads down. Critical to understand this concept. You need moisture. Single component foam will not fill very large and very wide gaps. Most of your panel-to-panel connections, it works beautifully. If you, however, are dealing with a system that requires you to fill a very large void, that's where you'll typically see the 2-component foams come into play. Most commonly, 2-component foams are very similar to the urethane foam that we talked about back in manufacturing of polyurethane panels. We have an A and a B component, the polyols and the isos. They mix together in the gun, and they expand based on the chemistry of the mixing of the 2 components. We don't need moisture in this case, and that's a good thing because it means that we can fill up a void as big as we want, and we don't have to worry about the curing issues of this foam. It will cure from the outside all the way through. If we try to fill that same big void with the single component foam, the moisture in the air will penetrate the outside 1/2 to 3/4 of an inch, and it will cure that big ball of foam as if it were a hollow ball or a hollow sphere, and the foam inside just collapses, and you no longer have a good seal. Don't make this mistake. Know how big the crack is that you're trying to fill up and use the right foam. Remember, 2-part foam can be a bit finicky. I want you to take the time to read the directions, understand that it has shelf life, it has certain specific things that you need to do in order to prepare that box of foam, like the proper temperature, the proper mixing, and make sure that you've got good control over that foam, because that stuff is not cheap, and you want to make sure that it mixes properly so that you've got the right chemistry when using a 2-part foam. You may find that you're going to find in the effort to seal all panel joints, in some cases, you're going to use a gasket. What type of gasket? Very similar to perhaps a sill seal material that may be laid underneath a plate, between a plate and a slab of concrete. This can also be used in between panels at panel joints. One of the tricks we'll use to help grow a joint, if we want to spread the panels apart a little bit, is literally to lay sill seal in between the panel, foam to foam connection. It helps grow the joint as well as give you a good tight air seal. Because remember, sill seal is a closed cell foam, so it acts in a very similar way that the core of the SIP does. The sill seal is just one form of gasket material. Now, there came a time in the SIP industry where we realized that there were installers or builders who were putting panels up, and they didn't quite get the concept of how to seal panels. So the industry came up with a belt and suspenders approach. This belt and suspenders approach is nothing more than applying an external seal on the panels. Now, where does that external seal go? Well, if you remember from our building science talk, we talked about always putting the vapor barrier on the warm side. It's true with SIP tape as well. So if we're building in the vast majority of North America, that SIP tape is always going to go on the warm side, which is the inside of the structure. If we happen to be building down on the Gulf Coast or in Florida, now we have our SIP tape, which is going to go on the outside because that's the warm side. The SIP tape goes on in addition to the other sealing techniques, which would be either the mastic or the foam. Where is the SIP tape most commonly used? In the roof assemblies. Why? Because as we said in building science, warm, moist air tends to accumulate up near the ridge or in the roof, and that's not where we want moisture to accumulate because we had a failure in our sealing system and that air came in contact with a cold shingled roof and started to condense. This SIP tape should be applied on all of your joints in a roof panel package. It's a good way to make sure that you don't have a problem in the future because somewhere condensate formed, leaked into your roof assembly, and all of a sudden you now have a problem with moisture in your roof assembly that shows up years, months, or years even later. Leads us into another weather-related issue. And this weather-related issue is, when do we put the SIP tape on? If we're using the SIP tape in the deep south, because we're in the south, the vapor barrier goes on the outside, which is the warm side. This actually helps us in a couple of ways. Not only is it our belt and suspenders for sealing, but it also is going to keep that bulk moisture or the rainwater that may fall from migrating into the roof assembly. When we're not in the deep south, now our vapor barrier is to the inside. That means the SIP tape has to go to the inside. But when we start thinking about weather issues and when is the roof truly watertight, because remember, it's not the panel that makes the roof watertight, it's the roofer that makes the panel system watertight. So now, if we put the SIP tape on too soon on the inside, bad things can happen if it rains. What's going to happen? Well, let's just say, for example, that your sealing in the inside of your panel is not completely 100% perfect. And that rain that falls, moisture gets down into our joint and tries to leak through the panel. If you've applied the SIP tape to the underside, that SIP tape can actually conspire against you and hold moisture into the panel and prevent it from drying back out. I strongly encourage anybody who's putting a roof panel package on, before you put your SIP tape on, let's make sure that that roof is watertight. That means we've got either black felt or underlayment, or better yet, a finish roof. Doesn't mean we have to wait to seal the panel joints. It means we need to wait to before we put the seal tape or the SIP seam tape on that roof panel package. Wait until it's watertight. Don't block water in there. It'll get you in big trouble. Let's talk about a few things that are surrounding efficiency of setting panels. This is a whole bunch of different elements that I'd like to point out that I just want you to think about, because efficiency is everything. We want to get this thing done because the quicker we get it done, hopefully we make a little bit more money on this particular project. In terms of good, efficient things that we can do while setting panels, first and foremost is good staging. If we can stage our panels in order, know exactly how we're going to set them, which is all done back when we were doing panel prep and pre-assembly, now we've got staged panels, which means the top panel is the one we need first. And that's an awful nice thing because it keeps us moving much quicker. Also, think about line of sight. If you're working with a crane operator or a forklift and you're up on a roof or you're on the far side of the building, think about how you might be losing line of sight or access back to across your job site by starting in the wrong location. Don't get out of whack and start in the wrong location. Also want you to think about plumbing and straightening the walls. Just because they're SIP walls and they're really, really straight doesn't mean that when you've stood them up, they're absolutely perfectly straight and ready for that floor system. You still may need to run a line down that wall and verify that it's straight. In terms of plumbing walls, I also want you to think about, before you finish nailing them off, make sure that you've put that level on that wall and made sure that it's plumbed before you even nail that bottom plate off. Because just having that wall leaning over a little bit and nailed up, then when you do have to plumb that wall, can put strain or tip or twist that bottom plate so that you potentially open it up to air leakage. Keep everything straight as you go. Also, be careful about sealing things too soon. Remember, we want to get as many panels up as we possibly can before we go back and commit ourselves to their placement. When I say placement, I'm talking about things like joint growth, or perhaps a panel that wasn't cut absolutely correctly by the manufacturer, and all of a sudden your panel joint doesn't happen where it's supposed to. For this reason, I typically will encourage installers to lay out all their panel joints, all their window and door locations on the deck before they start standing that wall up. That way, every time you stand a panel up, you're going to catch potentially those manufacturer's errors. And it's those errors that we want to catch ahead of time. So, do a layout on the deck, set your panels as you go, make sure that you're going to not have problems with the locations of point loads or any of your rough openings, and then go back and start sealing panels up if you're injecting foam, or if you're using mastic, you can go ahead and commit to the mastic as you stand the panels up. And remember, panels always do go together a little easier if you zipper them together instead of straight together in line. You want to use that zipper fashion to bring those lumber pieces together, especially when you're using lumber joints. It's those lumber joints that'll slow you down if you're not thinking about panel prep and making sure that they slip together nice and easily. In addition to labeling the floor, to making sure that they all the panel joints laying where they're supposed to, you want you to keep an eye on something what we call joint growth or panel growth. If you have a long wall that has a lot of lumber in it, it's that lumber that may not allow the panels to come together perfectly tight, and every joint grows 1/8 of an inch. And if you have, let's say, 8 joints, you're going to grow an entire inch. And it's that joint growth that when you get to the corner is now going to force you to have to cut your panel. This is the other reason when talked about earlier that you're better to have a deck too big than too small, because it accommodates things like joint growth. Keep your panels snug together as tightly as possible so joint growth doesn't sneak up and get you, because otherwise when you get to the end of the panel you're going to have to start cutting something. And it's much easier to stretch the panel into a larger foundation than it is to have to cut it off. So this is part of the labeling that I encourage you to do as well. Labeling is important. Not only do we want to label our panels, but we also want to label our deck. Know where your panels are in your system by labeling your deck. It helps you make sure that you've got the right panel in the right location. Trust me, the best installers in the world sometimes put the wrong panel up at the wrong time, and then they're just having to take it back apart. The other thing we want to label as we go is the electrical path. And that electrical path is going to be where you drill through your plate to get into either a crawl space or a basement for the electrician. We're going to talk a lot more about electrical work when we get into talking about other sub-trades and how we make accommodations for the electrician. But marking those holes and marking the location of those paths for the electrician is critical in him understanding what's going on inside that panel that he can't see. Make that communication for him and make it easy. The other thing that I'd like you to label and think about it, again, thinking back like a molecule of air, is where do I have a void in my panel? When we put panels together, is the foam not chipped out? Do we not have an area where something didn't go together quite correctly? And for instance, a forklift dug out a big chunk of foam. It's very easy to fill that back up by being able to inject foam inside that panel. But we can't do it unless we know where the void is. So that's where that black marker that you carry in your tool belt is sometimes your best friend. Take it out and use it. Be able to identify where those holes or voids inside your wall or roof assembly are, so that when you put on your insulator's hat and you're walking around with that can of foam, injecting foam into your system, looking for those voids, you know where to drill and inject that foam. At this point, I want to point out something that some people it's escaped on them, and that is the path by which we are putting panels up and how we have changed the order of construction. Now, what do I mean by change the order of construction? In traditional construction, we used to start out with foundations and then the framer would come in. Following the framer is the sub-trades, right? The electrician, the plumber, and the HVAC contractor. And after them, who comes up next? It's the insulating contractor. And the insulating contractor comes in behind all of these sub-trades. When you're putting up this SIP package, the game has changed. We take the insulator, we pluck them out of this progression of work, and we move them up here to the front where the framer is. The framer is the insulator. Why is this important? Because those 3 trades that come in behind you as the SIP installer, if they don't understand that, they're going to think that the insulator, as usual, comes in behind them. They're not going to be thinking like a molecule of air. They're not going to be sealing up their own work, and you have to keep an eye on them. The whole concept of installing panels effectively and getting them sealed up tight means that you understand that these trades may actually work against you when they do their work after you've done a perfectly good SIP installation. So know that you're going to have to come back after the trades have done their work and reseal, recheck, and verify that you've got a good tight system. Most of the work we do on tools and cutting and modification and sealing are going to really come out when we move into the phase 2 of hands-on work in this program. We'll look forward to seeing you soon.